And this will always feel like my job talk. Like, it'll be a long time before this room doesn't feel like my job talk. And I think I also used the joke before about how when I showed like a network analysis diagram, I thought, oh my God, who are these people? And that's a joke for the network analysis in the room. Never mind. All right. So this is about a tool that I've been building and building over the summer and started to use this fall. I got a CRC grant, the FSU CRC grant to do some exploratory work and some proof of concept work. So this is, the front end of this is a lot about system building, and then I'll get to a certain kind of research method that this applies. This tool is called Dragonrank. It has nothing to do with dragons. It has nothing to do with me going to Drexel. I'll save that for...
Well, you wanted it to be red black, right?
That was a little less drama than I anticipated.
You said dragon, it turned red.
If I had that kind of power. Right, okay, so this is about Dragonrank's a tool for doing a certain kind of list-based research collection, data collection. A lot of the analysis side of this method that I'm going to present has existed for decades, and there are folks, especially at UCI, who are using this a lot, but there wasn't a research data collection tool, think things like Qualtrics and SurveyMonkey. They don't do this the way I needed to be able to do it, so what you're seeing is a proof of concept to collect a certain kind of data to do a certain kind of analysis. It has nothing to do with dragons, everything to do with rank order lists, ordinal lists. It's a tool, among perhaps other things, it's mainly a tool for studying culture by extracting and analyzing cultural knowledge. Right, so asking people not what they do in a given social setting, but what they know about a given social setting or a given culture. I'm going to talk mostly, when I talk about the research, the research we've done so far, Abby couldn't make it today. She's been working with me on a study that I'm going to present. That's a sort of a functional beta testing of this, about a social media study that we're doing. But the goal, the studies that I'm launching this semester, now that the tool is sort of functionally confirmed to work the way I want it to work and generate the kind of data that I want it to generate, I'm going to move on to what I got that grant to study, which is questions like, which soft skills, please pretend that all of these spelling errors don't exist, or try at least not to have them distract you as much as they distract me. Which soft skills are valued within a given professional culture, right? So when we study any professional culture, some things are externally verifiable. There are things you need to know to do this, but oftentimes that truth isn't externally verifiable. There's certain kinds of truths about social media use and soft skills in professional communities that are not externally verifiable in that sort of positivist way. And don't worry, we're not going down that positivist route. Right? But there are questions that, like, what is the distance between Tallahassee and Atlanta that is externally verifiable? We can measure that distance. Right? We can ask questions, though, like what is the most popular burger in town, where we operationalize this term popular in a certain way. Right? So we might operationalize this as number of sales. Right? Popularity is a social construct, even more so the best burger in town, maybe a social construct. We can operationalize things that are objectively measurable, like sales. And we can either ask or we can use sales directly, or we can use sales as a proxy for best. Problem with doing that is that you end up in scenarios like this. This is the McDonald's cheeseburger. It may be the most popular burger in any town, certainly a town with so many college students. Is it really the best burger in town? But intuitively, we have this idea that you could get a sense of what people think here is the best burger in town, or the best smoke shop in town, or the best vegetarian food, vegan food in town. We have a sense that there are answers to that, that if there's enough agreement about them, we can treat them as if they're externally verifiable truths, right? We can come up with culturally correct answers. And that's the goal of tools like Dragonrank. And this all comes, this idea of collecting and measuring and analyzing the agreement among respondents to determine what the culturally correct answer is. This all comes from a field called cognitive anthropology. and particularly a method that they often use, cultural consensus analysis. For sake of time, I won't go into the difference between cognitive anthropology and cultural anthropology. Right? It's anthropology, it's the study of culture. In cognitive anthropology, they tend to do the sort of things that I'm here to talk about. Right? Extracting knowledge and analyzing patterns in that information to determine, for example, what cultural truths are. Right? So this Dragonrank is a tool to apply the informal model of cultural consensus analysis. This is something that I'm pulling forward from my dissertation work and applying some of the lessons I learned about how I couldn't do it with existing tools to designing the tool that I'm presenting here. So informal CCA is a set of analytic procedures that can be used to estimate the culturally correct answers. Right? And also, once in those cases where you can identify enough agreement among a given set of respondents that there is something like a cultural truth, you can then use that as an answer key. Right? And you can then, that answer key can tell you what the culturally correct answers are, and you can use that answer key to measure individuals' responses to determine how much certain kinds of individuals know. So in a I'll save the examples for like actual examples at the end when we talk about Yik Yak and social media. So this is a social scientific method from cognitive anthropology, but the way it's applied, we're familiar to the information science folks in the room because it uses a lot of factor analysis, just in a slightly different way. So in a very crude, traditional term document matrix, where you have a set of columns, documents, and a set of rows, terms, you can factor analyze those documents, and the more similar the columns are, the more similar those documents are. It's very good. This is not my expertise, but I think that's a pretty fair assessment of sort of a generic topic modeling using, in this case, a binary matrix of terms and documents. Right, so similar columns, similar documents. Fine. In consensus analysis, formal and informal models, instead of factor analyzing the columns, or in addition to factor analyzing columns, there's reasons to still do more traditional factor analysis. What you do is you transpose the matrix so that you're determining not the similarity between columns, right? You're identifying similarity and agreement between the rows. Right? So in informal CCA, what you have in the data in the matrix represents, so in a consensus model, each of your rows is a respondent. Someone has answered your survey and they become a row. The document becomes a set of themes in my case. We'll unpack that in a little bit more detail. And so, yes, question.
So if it's the similarity among the row, what's the difference of the two central tendencies? We calculate mean. That can be the similarity within row as well.
Sorry, yeah, so do that again. Say that again.
I mean, so in the basic statistical analysis, we use the means of mood to indicate the average of our respondents. I think it's kind of to calculate, so if you think about mood, it kind of similarities within your samples, right? Mm-hmm. So what's the difference of that way to calculate and your way to calculate?
If I understand your point correctly, not much, right? And as I go through the rest of the analysis here, see if that still holds. The main difference is that it's the transposition of the rows and columns, right? You're not interested here in these columns. You're interested in the rows because you're looking for similarity not between these documents or these terms or these themes or these concepts. You're looking for similarity between the people and their responses, right? So it's these vectors that you compare, right? And the goal of this is if you have a high level of agreement among those rows, the goal is to say, yeah, there's enough cultural truth here among these respondents to then go to continue with the analysis. Right, so high correlation coefficient among all rows lets you say things like there's consensus about best burger in town, right, given the way these respondents ranked the burger joints in town. Low correlation, assuming a good design, means either they have multiple cultures, right? So you can imagine a scenario in which you ask students a certain question and you ask townies the same question, and they have slightly different, or less slightly different cultural norms and beliefs and knowledge. So you can end up with dual cultures. With the data that I'm going to show about Yik Yak, the social media platform, we'll see there's another possibility if you have low correlation where you have a set of cultural beliefs, but you have enough outliers that there are people that it's not totally coherent, that there's subcultural norms that certain people, not a fully formed other culture, not a fully formed set of other cultural beliefs, but a small subset of individuals who deviate from the otherwise highly correlated responses to the survey. So if there's high agreement among if there's a high agreement among in a given matrix, you can generate an answer key of the columns. The correlation between the individual's row and the overall matrix can be used to determine the individual's cultural. The term that the cognitive anthropologists use is competence. I think that in our field, competence is used a little bit differently, so I just call this cultural knowledge. The amount of agreement between this answer key that you've generated and the individual's answers reflect how much cultural knowledge and how much that individual's cultural beliefs are in alignment with the culture, the cultural norms. Okay. So what is Dragonrank's role in all of this? Because the tools, many of the tools, as I said before, many of the tools that exist to do analysis, there's a whole R module for this. They exist, but there wasn't an adequate data collection method. So the main reason why I had to build a tool to collect this data comes down to challenges in doing rank order, to collecting rank order lists. Right? Using tools that already exist, I can ask people to, right, in Qualtrics, in SurveyMonkey, I think even Google Forms now has a way of accomplishing this. I give you a list of things and you reorder them by rank. It's pretty easy to do. But there are challenges, non-technical challenges to this. So in your mind, follow through with this exercise. All right, rank the following in order of how much you like them. Dogs, didn't see that coming. Those of you who know me know that that's always the first thing on it. Rank the following in order of anything. Dogs. Cats, you're welcome. Chickens, cows, mice. Right? So rank the following in order of how much you like them. And think for a second, do you consider this a particularly complex exercise? It's a pretty simple rank order thing. You can move these around in your mind and put them in order according to how much you like them. Here's a slightly more cognitively challenging ranking exercise. Rank the following in order of how critical they are to the welfare of a sustainable ecosystem. Dogs, cats, chickens, cows, mice. Right? Same framework, same in a lot of ways, but it's more to think about, right? So, but we might still want the answer to this question, and also we might have much longer lists, right? There's a lot of ways in which each individual exercise, right, and the overall exercise can become cognitively complex. So there are various ways in which researchers who want to generate this kind of data want to mitigate the impact of fatigue and survey bow out and all this stuff. So this is my very loose definition of cognitive complexity in this context. Cognitive overhead or complexity, the cognitive complexity is roughly equal to the cognitive overhead of each individual judgment times the number of judgments necessary to make. Right? So if I have a very simple thing like which is your favorite animal, that list can be longer before fatigue sets in, right? And then, as in the case of the second rank order exercise, each individual, where would you rank a dog? Where would you rank a cat? Right? How would you compare the two? Each individual cognitive task, is more complex, so that list needs to be shorter. There are other versions, and there are variations on that theme of complexity and ranking, which just want to give you an idea of the sort of challenges that this tool is aimed, the goal of which is to mitigate. This tool is supposed to mitigate those kinds of things. Okay, so Dragonrank takes a list of items to be ranked, constructs a balanced incomplete block triad designed ranking survey. I'll unpack this in a moment, but notice rank doesn't explicitly show up there. The tool is also, it's a web-based tool. It shows a running correlation metric. So when you release this survey, once Chromeback's alpha is high enough, you can start to look at this data in terms of, does it look like a single culture exists? And Chromeback's alpha is a measure of agreement in a matrix, so it's a useful heuristic for determining when you should consider looking at what your data is presenting, like looking at the quality of your data. And Dragonrank exports into a UCINet friendly format. UCINet's not the only tool, actually in a R friendly format as well, right? But UCINet is a pretty easy, straightforward tool. Steve Borgatti developed UCINet, and he was a big proponent of the first wave of this consensus analysis, more the formal models of consensus analysis. So UCINet is a pretty good tool to analyze this data. So when we designed, when this tool was built, it's not supposed to do the analysis. We don't need to do the analysis, but we needed to make sure that the data exported nicely, right? So it does that. So this is an example of the kind of exercise that, given a list of 10, 11, 12, 20 things, right? This is the kind of prompt that an individual gets when they do one of these surveys. I learned as a software sales engineer that try not to go live with demonstrations. I was going to show one of the surveys, but you never know when the Wi-Fi is going to take a moment off. Not that that ever happens in this building. I mean, it does. I've been in worse buildings, like in Fallujah. Sorry, that's not true. That's not true. Right. Huge shout at Fallujah there. I just like the way Fallujah sounds. Okay.